In this video, we'll learn how to use Excel to perform hypothesis tests for the difference between two proportions. Excel does not have a procedure unless we use the XL stat or the mega stat add-in to conduct a hypothesis test automatically for two proportions. But we can apply the formulas manually to find the p-value. And as long as the p-value is less than or equal to alpha, which is the level of significance, then we reject the null hypothesis. If not, then we fail to reject the null hypothesis. Okay, look at below. We have 3 steps to find the p-value. The first step is to find the test statistic Z0. To find the test statistics, we use the formula p hat 1 minus p hat 2 divided by the square root of p hat, multiply 1 minus p hat, and then multiply to 1 over n1 plus 1 over n2. P hat is the poor estimate, and it is found by getting x1 plus x2 divided by n1 plus n2. The p hat 1 is the sample proportion for the first sample, and p hat 2 is the sample proportion for the second sample. And to find the p-value, we are looking for the area under the normal curve. So if the p-value of the left tail case, we just use the norm.dist, the normal distribution function again, and we input the negative z in, and 0 for the mean, 1 for the standard deviation, and true is for the cumulative area to the left side of negative z. And then to find the right area, we just simply find the left area of z, of plus z, and then take find the left area of plus z, which is the y area, and then get 1, subtract that to get you the right value. For the two-tailed case, we just find the area of one of them, and then we multiply by 2 because they are symmetric. And if p-value is less than or equal to alpha, we reject the null hypothesis. If not, when p-value is greater than alpha, we do not reject the null hypothesis. Okay, let's take a look at this example. An economist believes that the percentage of urban households with internet access is greater than the percentage of the rural households with internet access. He obtains a random sample of 800 urban households and finds out that 338 of them have internet access. And he also obtains a random sample of 750 rural households and finds out that 292 of them have internet access. We want to test the economist's claim at the alpha level of 0.05 level of significance. So in this problem, we are talking about the percentage, right? That is the proportion. There are two populations. One is the urban household. We call this is the first population. And the second one is the rural household. This is the second population. Now, for N1, we have 800 urban household. So N1 is 800. And then 338 of them say yes, they have internet access. That is X1, right? And then for the second sample, we have 750 rural household. That is N2. And then 292 of them say yes, they do have the internet access. So that is X2. So we have N1, X1, N2, X2, and the alpha level is 0.05. Now, we always assume that P1 is equal to P2. The first proportion is equal to the second proportion. We always assume that for the null hypothesis. And now the claim is an economist believes that the percentage of the urban household, which is the first population, is now greater than, right? So P1 is now bigger than P2. This is the claim. This is the one that we are looking to test. Okay, so first step, we need to find p hat 1, which is x1 over n1. We got all the value up here. and you just have to plug in the calculator or using Excel. And then P hat 2, X2 over N2. You also have everything here. You can plug that in. And then now, to find the poor estimate P hat, we take X1 plus X2 over N1 plus N2, and this is your P hat. So we have P hat 1, P hat 2, and P hat. And therefore, you can find the test statistic Z0. We get the value from these, and then we use the formula P hat 1 minus P hat 2, and then the square root of P hat 1 minus P hat, and the square root of 1 over N1 plus 1 over N2. So I just use everything, I plug in this formula, I get 1.33. Remember, 0 is always at the center. So 1.33 is a little bit to the right of 0, 1.3. And this is the right tail because P1 is greater than P2 is the right tail. Or you can see that the arrow is pointing to the right. So this is the right tail. So I'm looking for this area from the right of 1.3, and that is my p-value. Okay, this is the area of the normal curve, right? And this is the right area. So we have to find the left area and then take 1, subtract that. So what I do here, I need to find the left area, the one that I just highlighted here. So left area, and you know that the left area, again, norm.dist. And I'm looking for the area from the left side. The norm.dist function always returns the area on the left side. So we put in 1.3, and the standard, the mean is 0, the standard deviation is 1, and we put 2 because we want the cumulative, the left area. So this is my left area, but I'm looking for the p-value, which is the pink area to the right. So to find the right area, we just simply take 1, which is everything under the curve, minus the left area, minus this one, so that I can get the pink area, which is the right area, or the p-value, or 0.0968. Let me check again. I think I make a mistake here. 1.33. Yeah, I'm missing one value. Here we go. This is the correct answer. So p-value is the right area, 0.091. And this is bigger than alpha, which is 0.05. So we do not reject, we fail to reject the null hypothesis. If we don't reject the null hypothesis, that means we don't have enough evidence, or there is insufficient evidence to conclude that the percentage of the urban households with the internet access is greater than the percentage of the rural households with the internet access. So we don't have enough evidence to support the alternative hypothesis.